Now, people will talk about acid rain, but the fact of the matter is that normal rain is naturally acidic. A little. How much? Well, it depends. Well, that's usual. Everything depends, right? Depends on a lot of things. How much carbon dioxide gas there is and what the temperature is. So pH of rainwater. It was pure water. To start with, we would expect a 7, right? But it's not, because it falls through the atmosphere, which has some carbon dioxide in it, and it will dissolve some of that. When it does that, it will create carbonic acid. Not as acid as in your Coca-Cola, but yeah, there it is, carbonic acid. And here is the molarity of it. Ooh, 10 to the minus 5th. Well, that's not very much. And here we have, for the first one, that's the only one we're going to worry about, thankfully, right? We're going to use about the first one and then see what else we need to do with it. So the Ka1 is given to us, and we want to know what is the pH. Here's the equation that we're going to use. Now, I want to point out something. They do this as a sample exercise in the book, but I'm going to go ahead and do it myself without the simplifying step. And you should compare the two ways so that you can see what goes on. The simplifying step makes it sound as if there is more difference in the pH than there actually is. This is not surprising. It's a simplifying step, so it's going to be a little less accurate, and so you get a bigger difference, okay? So we should not be surprised by that. Now, what are we going to do with this? Well, we are going to use a rice table because that's what it's all about. So what's going on? We're going to use this for our rice table. Let's go ahead and put the reaction in then. Here's the carbonic acid reacting with the water, forming an equilibrium, hydronium ion, and hydrogen carbonate ion. Okay? Separate reactants from products. This is just the water. We get to ignore that. What's the initial condition here? Initially, they told us 1.4 times 10 to the negative 5th molar. None of these, because it's initial. Change. Well, hey, if there was none of this, some of it's going to come into existence. Every one of these that happens, one of these is going to happen. How did they come into existence? Because this fell apart. Equilibrium, let's add those together. 1.4 times 10 to the negative 5th minus x. It means x is going to be less than that number, right? This is just going to be x. That's going to be x. Oh, good. That's not so bad. We're going to end up with a quadratic equation out of this. That's x squared plus 4.3 times 10 to the negative 7x minus 6.02 times 10 to the negative 12 equals 0. Where did I get that? Well, remember what we're doing here. We're doing Ka1 equals x squared over the 1.4 times 10 to the minus 5th minus x. And we know what this number is because they gave it to us. It's right there, 4.3 times 10 to the negative 7. Okay? And if you work that around, you're going to end up with this. Okay. Then you go back and say, I'm going to use the quadratic formula and figure out what x is. When I figure out what x is, that's going to be my hydronium ion concentration. So when I solve this, minus b, Well, since it's already a minus, I only have to worry about the positive one. The 4.3 times 10 to the negative 7, it gets squared, and then minus 4 times this. Okay, so it turns out to be that's a point right there. I'm not sure that made it any better though. 10 to the negative 11, square root, all of it over 2, because there's only 1 there. We're going to get an x equals 2.25 times 10 to the negative 6, and that's representing the concentration. So if I want the pH, it's minus the log of this. Which gives you a pH of 5.65, which is on the acidic side, which is what it should, it should be on the acidic side. And if you just go and check this and how it was done, and then check how they did it with the simplifying step, then you'll notice that there's enough difference that you might care. Maybe.